Hello, everyone, and a very warm welcome to today's webinar, Infrastructure as Code for Icinga with Terraform. My name is Bram. I'm COO at Icinga, and I'll be hosting today. Our speaker today is Bram, who I'll properly introduce in a moment. Before we get started, just a few words about Icinga. For those of you joining us for the very first time, Icinga is an open source monitoring solution built and maintained here in Nuremberg, Germany. And we've been around since 2009. And our goal is very simple: to give IT teams full visibility into their infrastructure, meaning servers, networks, clouds, containers, Windows machines, without vendor login and without compromises. The core is Icinga 2, and around it sits Icinga Web, which is the web interface, the director for configuration management, Icinga DB for data storage, and a growing set of modules and integrations. People run Icinga on a handful of hosts at home, but people also run Icinga across hundreds of thousands of services in production. The stack is always the same. And that's the very short version of it. Today is not about Icinga itself, though. Today is about how you configure it, which brings me to today's topic. Today's session is about managing your Icinga 2 configuration with Terraform. Infrastructure as code applied to monitoring. A quick frame for anyone in the audience who hasn't worked much with Terraform before. Terraform is a tool originally from HashiCorp, now part of IBM, that lets you describe infrastructure declaratively in configuration files. You basically write down what you want. This may be virtual machines, this may be network, databases, this DNS record, and Terraform talks to whatever provider sits behind that resource. That could be AWS, Azure, GCP, could be VMware, GitHub, Cloudflare, and many others. It then makes the real world match what you have written down. If something has drifted from your code, Terraform plan shows you the difference, and Terraform apply reconciles it. The result basically is that your infrastructure lives in Git, and using that, you can review changes in a pull request. You can roll back. You can spin a duplicate of an environment from the same code. I guess that for a lot of teams in the audience, that's already how servers, networks, and cloud resources are managed day to day. Monitoring, however, often sits outside of that flow. Hosts and services get provisioned by Terraform, and then someone clicks through a UI or edits config files by hand on the monitoring side to add them to Icinga. The two configurations often drift over time. A host gets decommissioned, but nobody removes the check. A new service goes live without alerts. Most of you have probably seen some version of this. The Terraform Icinga 2 provider aims to close this gap. It speaks to the Icinga 2 API directly and lets you declare Icinga objects like hosts and services and notifications and so on as Terraform resources. The same workflow that your team already uses for provisioning, plan, review, apply, commit to Git, now covers your monitoring objects as well. And that's what today's session is about. Not the theory of infrastructure as code, but the practical workflow, how to set up the provider, how to authenticate against the Icinga 2 API, and how to actually manage your configuration, monitoring configuration as code. And this is also the agenda of today. We will wrap with a live Q&A. So remember, if you have any questions during the session, just post them in the Q&A panel or in the chat. We will come back to it at the end. A very quick word about the speaker today. The speaker of today is Bram Vogelaar. Bram is head of infrastructure at Devo team. He's a HashiCorp ambassador, a longtime Icinga user, and most relevant for today's session, he's the maintainer of the Terraform provider for Icinga 2. So you're hearing about this provider directly from the person building it. And with all of that said, I would say let's get into it. I'm delighted to hand over to Bram, who is going to be your speaker for the rest of the session. Bram, over to you.
Thank you, Blair, for that lovely introduction. Yes, I am currently still the head of infrastructure for Devo team G-Cloud in Netherlands. So we also going to see some G-Cloud today, but mainly we're going to focus on terraforming Icinga. As Blair said, I'm old enough to have used Icinga before it was called Icinga 2. And I was a heavy Puppet user. And for those in the audience that used Puppet before and the way the Puppet modules around Icinga specifically worked, it could take, so not only does it's annoying to do it manually, and then you always forget because we're humans and we hate repetitive tasks. So things like Puppet, Chef, in my case, Puppet, we could apply code to the desired state of our platform. But in the way Puppet worked, it would do a Puppet run on the node that it just brought up. It exported its resources. Basically, it would say, I would like to be monitored for the following things, right? Things to be discussed. That would be picked up by the Puppet server. And then the next time the Icinga server would come around asking, look, who needs to be actually monitored and what should be monitoring on that node, it could take up to an hour for, mostly more than an hour, right? It would take, because these Puppet servers, nodes contact Puppet servers once every half hour. So it could take up to an hour plus however long the Icinga run would take. So as Blair said, like these nodes could be unmonitored for an hour, or if you do it manually, for even longer. Perhaps I should step back a little bit more about who I am. I officially went to school to become a molecular biologist, but I'm lazy, not the work-shy lazy type. But if anything can be automated, it should be automated. And this is how I got into infrastructure as code, and this is how I got into programming. So to me, naturally, the emergence of Terraform as an infrastructure as code tool, so describing what a system should look like, made a lot of sense to me. So I have spent a lot of time with Terraform, and I am also one of the maintainers for the Terraform provider. So what these providers do, they basically wrap, in this case, Go code around an API, and around this CRUD API, so create, read, update, delete, and you add those to your desired state, right? We're going to describe a node, it needs to be monitored, we need to check its SSH port, it might be a web server, it might be a database server, right? So we actually want to describe in code and make it repeatable as well. Right? We all have these fire and forget scripts that we can only run once, and when it errors out, you can't run it again because the state is somewhere borked. And with Terraform, it will go out into the world and check what's there versus what it thinks it should be there, and then comes out up with a plan to build out new. Well, adds the step. It adds a step to the plan of what should happen to reach this desired state, and which spoke to me a lot because that's pretty much how Puppet also worked. So let's. Well, how does it work, right? For the people that haven't used much of Terraform, we have a standard setup. Usually, there's a main TF where, okay, in our case, it's fully empty because we're going to build it up. And then there's usually something called versions.tf or provider.tf, and that's where you declare a list of required providers. Usually you also say, let's declare a required version. In this case, you're probably going to be fine with anything over 1.3. And since actually the language, the functionality inside Terraform is quite small-ish. It does some basic functionality, it does some functions. So let's say it can do math, it can do random, it can do up and down. But so most of the stuff will come out of declaring a required provider. In this case, we're going to use Icinga 2. Me and my lovely IDE will actually start prompting a lot of stuff. I still don't know why it's prompting 0.5 because we released.
If we should see your screen, I think this is missing right now.
I did the thing again, right?
No worries.
Sorry. Yes. People have been in webinars with me before. No, this is an issue. Sorry. Yes. So there's my beautiful IDE. Let's start this again. Yeah. So while I was talking, I was building up my file. And here we have in the versions.tf the Terraform block with the required version. Now we're declaring Icinga 2 to be a required provider. In that case, if we let's change the folder, if we do a Terraform init, that's a terrible typer. So here you'll see that it will try and download the required providers that we need. In this case, just Icinga 2 at version 0.6, and it declares it's been self-signed by us by the key that we've shared with HashiCorp. I scroll quickly over this little bit because this is also the machine I developed this Icinga provider on. But for the sake of this exercise, we can ignore this bit. Of course, we need to tell Terraform where our Terraform instance is not our Terraform, our Icinga 2 instance is living. So in this case, that has what Terraform language calls a provider block. So it will say, in this case, provider Icinga 2, because that's the one we'll be using. We need to add a couple of things. We need to tell what the URL is, what the user and password is that we're going to use today. And in my case, because it's basically a Docker Compose of my local machine, we'll need to accept that this will run without TLF certs. Now we can always try Terraform plan. Well, no changes, so it should all work. And the simplest example that we can show people is adding a node to be monitored. Let's add that to our main.tf. So in our case, it's a resource of type Icinga to host. The red line under the name basically means we need to set a couple of variables on. Most important ones is the host name. Let's choose something quite poorly, but who hasn't called something foo? In the case of host, we need to give it an address. So let's hope this address isn't in use on my local address on my local network. And what we need to tell it, what is it going to check? In this case, it's just going to do a simple host alive. Oh, and this is what I forgot. We need to give it a name. So it is a resource of resource type Icinga 2 host, and it's going to be foo. If we run this plan again, you'll see that Terraform has gone out to Icinga and has worked out that the Icinga of the host foo isn't in the list of things we monitor yet, and it proposes it's going to add it. Right? It's going to say here it's going to get created. And then it's going to tell us some basic information of the things it's going to add, which it then summarizes at the end. It's going to add one thing, it's going to not change anything, it's not going to destroy anything. We run the apply now. It's going to do a basic plan again, because in between the time that we planned our plan of attack and we want to apply it, life may have changed outside. So it'll always plan again, and then it will ask for confirmation. And here we actually been told, that's what I did wrong. So what has been told is, yeah, you asked for no TLS, but you actually sent me to a TLS endpoint, so screw that. And so when Terraform cannot reach the desired state, it will just error out and ask the operator to fix whatever is wrong. Usually with a fairly decent error message, but that pretty much all depends on the provider that is written. And in this case, it's fairly happy with the error that it showed me. So in this case, let's apply again, and let's confirm. It still errors out. Why do you error out? See, this is always happens when you do things live. That's for one. Let me double check if my local Icinga is actually running. It is. And as I said, sometimes the error you get back isn't particularly helpful. So here it just says end of file. Feel free to do with that what you want. So let's ask. I think it's. No, I want logs. So in this case, I just want to know what is going wrong. And we want to, so in this case, Icinga has a lovely project called Docker. Well, it has a Docker Compose setup in its GitHub repository. This is also what we basically included in the provider. So if you want to test the full stack, this is what you can use. And this is what I'm running right now. So in this case, I just want to see the logs for the Icinga 2 container, which I'll follow. In this case, I'm just going to.
So in the meantime, we're getting live hints from some Icinga developers that the URL probably has to be HTTPS, because Icinga doesn't listen to HTTP.
I screwed up this version. Why is it? No, this is the tunnel. And let's show you the lazy version. We can also not wait for approval. So just add auto approve. In this case, what we're debugging is it's not picking up this insecure, which we can also force onto the command line, which is something we haven't discussed yet. which is what this looks like. So you can always add the configuration parameters that we have available to us in the Icinga 2 provider. You can always add those as environment variables, or in this case, just hard-coded on the command at the same time. Okay, then I probably have used the wrong user. Which I think is Icinga Web. So yeah, I've been preparing a lot and apparently haven't correctly reset this thing, but it gives you a good overview of, you know, the handles and knobs you can twist. In this case, I did get it right, yay me. And you saw that adding this node took almost no time. I did. And now, in the overview, we should have another host. Basically, foo is pending. It's gonna stay pending until it errors out, because basically, you know, host foo isn't actually available on my network. But this is how easy it is to add a node. If you want to remove said node, and well, if we comment that out, which basically means we tell Terraform no longer care about this node. It's what it does if we give it another apply. Basically, we say, you know, we do not want to manage the configuration of this host. Then what we see, it adds a destroy, and the host goes away. In Icinga, that goes quite quickly. Of course, we have similar stories about host groups, right? In Icinga, we can stick things in host groups. In this case, let's do worry about our host, and in this case, let's also make a host group for nodes. In this case, on inventory, let's call this bar, host group bar. Yeah, let's give it a test. So let's not auto-prove. Let's have a review of what we're actually doing. The host is going to come back. That's okay. But let's say, you know, we got the IP wrong. Well, no, let's do that in a minute. Sorry. So yes, let's make those. Boom. Creating a host group, a host, and host again. Let's say we didn't like the host group bar. Let's call it bar barbecue. And if we plan, well, apply that again. Let's see the plan. Actually, the way we implemented the resources at the moment, that in Icinga provider means it's going to delete the old one, it's going to create a new one. We're still working on an in-place update functionality. Yeah, we're working on it. We did a lot of work over the summer updating the provider framework that's underneath it, and now we can actually work on the developer experience that you have with this program. But in the version I have here, it's unfortunately still a delete and a create, but it goes very fast. Should we be able to? What else shall we do? We can, for instance, now we just do a host check. Let's say we also want to add a monitor another service. In this case, we want to check if the SSH port is available on our little host foo. If we plan that one, it basically will add the service for this host. Let's say yes. Again, super fast, which I'm very impressed with, both for Icinga and the provider itself. And we should see something pop up soon. Oh, 2 services, yes. So I did the ping. That's the local as the host alive, and now we're also checking if SSH3 is check is available. Well, if it's if it's working or not. In our case, of course, it's not, because host foo is an imaginary host on my local system. And there we haven't implemented all the resources available on the API, but the most important ones, I think, will next be check commands and notifications. That's pretty much it. And we can create users. So check commands, there's still, we're fighting a little bit with how things in Go work versus how things in Icinga and PHP work. So let's add this particular check command. So elaborate inheritance, like you might be used to in Icinga plain text config files, is not available, but you can get most of the more plain ones in there. So in this case, resource of resource type Icinga to check command. We're calling a check command. We're not using any templates at the moment, just going to ask for a certain command to be run locally. And let's add that one. Well, is it interesting to show this here? No, I think it's not going to do a whole lot of stuff. What was that? Notifications. That's the most important one. I mean, it's basically a rinse and repeat. Well, for that we need a user. We want to notify. In this case, type resource Icinga for Icinga2 underscore user. Let's call this Bram. And this is an interesting combination, because here you start seeing something go red, because notifications depend on users being present. So in this case, I have declared this depends on relationship, and this is now, it depends on user Bram. And here we can also user Bram and directly to his name. So in this case, yeah, we're creating my user, and we're going to make sure that we can send notifications towards me. Let's apply this again. Yeah, it's probably easy if you ask for, if we say Bram should be able to be emailed, then we should add my email address. Let's see what it does now that I've changed the code since planning. Ooh, it errors out. May still error out. Yeah, as I said, some of the error messages that we're catching is not the greatest. I think time-wise, I probably want to go into the next bit where I'm going to, yeah, the 25% 30 minutes previously been quite theoretical, right? We want to add a user, we want to add a host, but how does this work together? That's what I'm gonna switch on to. In this case, what I've done is I have created a network and a subnetwork in Google. In GCP, I've added an Icinga server there, and give them some details, right? It's going to be in Ubuntu. It's going to have some basic stuff installed, which this is not required because this is stuff I don't need. I've given it a network interface, and I'm sticking it in a project Icinga. And to make it a little bit more secure, I haven't given it access to the outside world. I've used an identity-aware proxy, which I'm gonna start in a minute. So this is listening. I'm gonna start my identity-aware proxy of a tunnel. Before I do that, I need to turn off my Docker because otherwise I'm gonna get a port conflict. So first, the two main things that we want to expose is the interface, which I've been showing you on and off. And the other place is I want to make a connection to the API, right? The most important thing in our setup so we can talk both to Google and to Icinga at the same time. As always, start with our Terraform init. Again, I've already set it up a little bit, but let's have a look at what's happening there. Terraform project have a fairly standard layout. We have a main.tf outputs, which we're not using it today. The versions.tf now we'll have two required providers, Icinga 2 and Google. And before I make the same mistake again, let's copy and paste the correct credentials. So what I've set up for you today is slightly basic setup of what I usually do in these cases. I've created a module. In Terraform, anything that is a module, if anything that's a directory is considered a module. So in this case, I have a VM module that we use to create VMs. The only thing I need to tell it is what's the thing going to get called. And if you look at this VM, it's fairly similar to how I created the Icinga server itself. In this case, Terraform has the ability for data resources. It goes out to, in this case, Google for GCP, and it looks up two things for me. What's the most recent Ubuntu image, and can you give me information about the subnet I would like this node to live in? And then I create the instance. We pass in the variable VM name that we've given it in the main TF in the top module, and then it's going to run basically the same in a similar place in a similar fashion as the server itself. I have for the VM created an output. So what you can ask Terraform to do is when it has created a resource, it knows certain information about said resource. In this case, I want to output two things. It's the VM name, the thing that we created, which we inserted in the beginning, but it's always good to output the actual thing that was created, because sometimes there's Google is fairly good in that it uses the name that you've given it, but there's other cloud providers that do things like lowercase everything. In this case, they also want to output the IPv4 address from the first network interface, which are now in Google's situation is basically holds the private IP address. The beauty of that, why do I actually need those two informations? Because I want to pass them into the Icinga module that I've written. Because I want to observe these nodes automatically. So in case we have the output from the module, the VM module, and that we stick it straight into the Icinga module, which basically does the VM. Well, it adds the VM to Icinga just like we did before, but now with actual data from a node that is being spun up as we speak. So let's tempt the demo gods again. So where does my VM name come from? Usually there's a CMDB or something, or in this case, it's hard-coded local that I feed into this file. Let's see if this will work. So in this case, if we review what is going to get added, right, it's going to add two things. It's going to add the compute instance, and it's going to add it immediately to Icinga with the correct information. Let's tempt the gods and do this. So now you see, because there is a dependency on this VM being created first, because otherwise you do not know what IP address is going to get given. Terraform automatically works out that there is a implicit ordering, and it will order the resource it needs to create in that order. God, we have the same issue as before. So happens if you use your Mac instead of your daily Linux driver. Give me 1 second. So it sees, right, we had an error, it errored out, but it already had created the GCP node. So now Terraform has worked out, I already have this node, I already have the information. So the only thing I need to do is add it to Icinga with the name that's been outputted, with the IP address that's been outputted from this module. Nice. So some of the gods have helped me. So it does look the same, but that's I promise you it's the actual it's the actual thing running in GCP right now. Icinga admin. Yep. There, what I'm running there is the same thing. That is actually the same Icinga server setup as I've described before. It's a Docker Compose. And here we actually see this Icinga 2 client has been added for being monitored straight away. It reports the correct IP address, and this one should hopefully start working if I haven't forgotten to fix the firewall again, so it actually is allowed to ping in my little VPC. But it's starting to come alive, basically. Oh no, it's got full packet loss. So somewhere in my firewall setup, I've made a mistake. That's a shame. What else did I forgot to discuss today? So it's code. So let's use it as code. Let's treat it as code. So in this case, I don't actually have a running GitLab of GitHub Actions pipeline for this, but it's code. So if we were to do git init, in this case on my system, as I said, I'm lazy, so G is alias for git. Let's add all these files into our system, although I always forget that we need a git ignore file. That says anything in the Terraform folder should be excluded. Because that's basically where, in my case, where Terraform keeps its local admin. So in this case, when we talked about Terraform downloading providers, it actually downloads it into this folder. So there's a bunch of binary blobs there that we do not want to have in there. So that's what I highly suggest you do. What Terraform also does is what we haven't discussed here today is it creates a log file, which you should definitely add to your Git history, because here it actually says the previous person that has run this thing has locked the version of the providers to a certain version, in this case, Google 7.3.3 and Icinga 2 to 0.6. So if a new version has come out in the meantime between me running it and you running it, then this file will make sure that we both run the same thing. Let's close all. Let's clean a little bit of house. So in our case, if, for instance, let's say, you also agree that the Icinga 2 client is a bit of a boring name. So let's call this thing webinar 1. We can both see this in code, so we can just basically review the changes in a Git pull request or whatever GitLab calls it. So we review this as operators, or if you have an SRE team or platform team or some authority relationship where people are allowed to add their own things, or you have juniors that you as a senior would like to review, you can basically have a standard Git workflow that you have. And the beauty of this is we can also basically just Terraform plan this again. And of course, nobody reminded me that I need to do this insecure thing again. And here you'll see that there is a little bit of a dance again with what Terraform is going to, well, it knows it needs to change, and this is the proposal on how it thinks to get there. So in this case, it has decided that both the host itself and the Icinga host definition needs to change. We discussed this, why it needs to happen on the Icinga side, because we don't actually have an update configured yet. But here, I know if you change the name of a Google VM instance, it forces a replacement. So it will, unfortunately, remove the host and create a new one, which is basically what it tells us at in the plan. It will add 2 things and will also destroy 2 things. In this case, yes, let's do this. GCP is also having a fairly quick day. Let's see how long this takes. So Blam, if you have any questions in the meantime, we can have a little
I
chat
do.
about this. Okay.
Perfect. One quick question while we're waiting. Do you happen to know if this provider works with OpenTofu as well? I know you're a HashiCorp sort of guy, kind of, but the OpenTofu project has been around for a while now. Do you know if it's fully compatible with the Terraform?
I haven't run it against OpenTofu in a while, but I see no reason why it shouldn't.
Right.
The both tools still use the same SDKs. I don't use any of the special things that have been implemented in either of them.
Right.
Our provider is fairly vanilla. But I am willing to, if we have enough time, to do a live test.
Maybe we can edit at the end if we have some more time left. We can live try it with OpenTofu as well. I think the run is over now. You may continue, and I will add some more questions after that.
So our old node is gone. That's why we get the error on the side. And here the new web is already, the new webinar is already back, in its pending state. And that's basically, also taking into account we agreed last 10 minutes is
perfect.
It's chat time. I think we
thank you, Bram. Thank you very much for showcasing the capabilities of this provider. As promised, we do have some questions at the end. One of them being about managing the configuration and especially validating the configuration in pipelines. Now, if you think of a practical workflow in a larger organization, you will most likely have a Git-based work tree. You will make your changes and push them, maybe create a pull request. How do you do it in production in terms of a pipeline? Do you recommend to have any sort of pipeline at all that does some frequent checking on each pull request, or what's in practice? What's the best practice here?
Always have a pipeline. That should be your default answer. As I said, I think at the top of our webinar is humans are incredibly bad at repetitive tasks. So you should definitely run this in a pipeline. If only that, your laptop might be gone, you might be on holiday, someone should be able to review this on your behalf, or you should be able to review this as a team. So you need to have a central place where this happens. It also makes sure that you don't get into it works on my laptop situations.
So if you would create wrong configurations with this provider, like entirely wrong, it will drop out with an error, obviously. What about invalid configurations if they are technically right, but in combination with existing configuration, they are invalid?
That's still an issue. This provider does not do any validation of any kind for that particular situation. That's not really how Terraform in general works. It has basic validation things. So if you are into Terraform itself, right, the HashiCorp, now an IBM company tool, then there are things where you can have in its paid for product, they have possibilities to validate a little bit more deeply, for which you need to write the validation test itself. I always suggest basically having two Icinga instances, one where the infra side of the house develops their Icinga configurations like you would do normally, and then have a promotion system for your code to go onto your production Icinga instance where you can do these types of things.
Right. So one of the attendees is suggesting to have a separate validation in the pipelines. What do you think about it? So basically running Icinga 2 daemon-c, which it's typically used on the local Icinga node to validate the whole configuration, including the API generated part.
I am not sure that will work for things you ask of the API.
Right. So it would at least require to have the full Icinga 2 configuration available in the pipelines. So if you manage your configuration partly in configuration files, you would need to ensure that each and every aspect of your production Icinga 2 configuration is also available in the Terraform pipeline. Otherwise, even the Icinga 2 daemon would not be able to do a full verification of your changes. Now, managing these types of configurations with multiple engineers, we already talked about having a Git workflow in place, having pipelines for testing in place, probably also for deployment. Is there anything else people should take care of when managing, especially maybe the monitoring configuration with this type of workflow? So if there are multiple engineers making changes?
I would it's not necessarily something Icinga related, but usual standard Terraform rules apply while working with multiple people. So have something like Atlantis in place that locks a workspace or you locks your project to a single pull request, so that you cannot have two competing pull requests doing things on the one instance. If that makes sense.
Yeah, it does. Last question from me for today. If you're using this Terraform provider and someone makes changes to the configuration through another channel, like the Icinga director configuration files or API, so there are multiple ways to configure Icinga. Does the Terraform plan detect the drift, or does it still try to apply and override it?
So it will not touch Icinga director things that are configured, because they get, as I understand how Icinga works, get stored in a different place. But if there's something, if for instance, let's take the example of our host foo. If you go in manually API and change something about host foo, Terraform will try and fix it.
All right. So yes, there are multiple ways of configuring Icinga, including configuration files, Icinga director, which uses the API, and other tools like the Terraform provider, which also use the API. We typically recommend users to not mix those configuration ways of configuring Icinga, not because it doesn't work. Technically, it works. However, we see users struggling and getting confused about what they configured where. So having a host being added through the API and the host group through the Icinga director and the members through another way creates lots of confusion. So we typically don't recommend to mix the ways of configuration. Yes, said that, I would say thank you very, very much, Bram, for joining us today. We forgot the OpenTofu thing. Sorry.
Yes, we
have one more thing left.
I manhandled my system into having the correct tofu again. Let's see, apply. So if we do.
This is the most recent OpenTofu version, I guess?
Yeah. Seems to work.
Seems to work. As we can see, even with OpenTofu, the same provider still working like a charm. Now, one last question, maybe if there's a minimum required version to work with the Terraform provider, I would say no. Of course, there is a minimum required version, but all of the latest Icinga 2 versions have an API. It has not been changed in the recent years. So if you run one of the last 2 or 3 major versions of Icinga, you will be fine, because we did not make any changes to the API in the last years. Great. Finally, thank you very, very much, Bram, for joining us today, for taking the time, presenting this for an hour to our audience here. It's much appreciated from us and also from the audience. So thanks again. We will continue with our webinars, of course. On June 30, we will have a webinar about OpenTelemetry. So most recently, we've added OpenTelemetry metrics support to Icinga 2. So you can integrate Icinga 2 with plenty of different open source time series databases like Prometheus, Victoria Metrics, Grafana, Mimir, and many more. So if you would like to learn more about how to use OpenTelemetry metrics with Icinga 2, make sure to register for the next webinar. We posted the links in the chat already. And yeah, thank you for joining us today. Thanks for being with us. Make sure to tell your friends and family about Icinga, of course, and see you the next time. Thanks, Bram. Bye-bye.
You're welcome. Bye-bye.